we taping?
Mm-hmm.
Okay. Take one. Hi there, I'm Bill Cozzolino, and running the camera is my lovely wife, Joanne. And we have a plasma generating device that'll produce plasma flame at a spark plug. I know you've been trying to do that for a long time. Just got it running today. I'm going to talk briefly about it before I put it in the car and show you that it works. And then when I get it in the car, we're going to give it a test drive tomorrow. And I'll give you the blueprints or the schematics and everything. So basically what we have is a series of diodes. Can you see the diodes here? I think there's way too many. I haven't done tests on them yet, but I'll give you the number of the diodes. There's only about $15 or $20 worth of diodes here if you get them from the right place. Got them run through a fuse. I have a half-wave bridge rectifier, which is actually 5 of those same diodes. And I have a microwave oven transformer that is in series with the line input as a ballast to ballast the input. I can run it without that, but it'll burn up the spark plug like a welding electrode. The ideal thing here would be a sensible reactor. I have all of the spark plugs wired. You see the spark plug here. I have the lead for the DC voltage coming down onto the tip of the spark plug in here. So the spark plug has both the high voltage and the rectified 110. And this fell out, but that's okay. Okay, so I've got all 4 of them hooked up. Number 4 cylinder now, the plug wire's pulled off of it, and it's pushed into old dirty spark plug I had laying around. And I'm going to start the engine, and you'll see the normal spark. Then I'm going to plug this device in right here, and you'll see that we get the plasma spark for burning water, hopefully. Can you see it in the viewfinder? Gonna plug her in now. Nice little plasma spark. Unplug it. Plug it back in. Again, without the mott in series with the line input, it really burns up the spark plugs in a hurry. We had a saturated reactor. We could adjust the current flow really easy. So that's it. I'm going to shut it off. Going to install it in the vehicle, and we'll take a test drive tomorrow. Is the red light on? Okay. Bill and Joanne back again, and this is, what day is it? Saturday.
September 6th.
September 6th, 2008. This is the day after the night before I showed you the sparky thing last night. Anyway, we now have a plasma flame lacing into all 4 plugs. So we're running on plasma. I hooked it up on 1 cylinder and it still worked, and then I hooked it up on 4 cylinders, and what happened is I forgot about crossfeed on the spark plug, so I had to build a little crossfeed protector, but I'll show you that. Anyway, I mounted the 10 amp, got an on-off switch, and I mounted the mott down in the firewall. This is a 1976 Volkswagen camper bus. It's standard 2-liter air-cooled. It's fuel injected. It's air-controlled fuel injection. It's a Bosch product. Works pretty good. I'm not sure how I'm going to put the water in it yet, but we're going to get her done. Anyway, if you come in here, there you see down here the, you get a good shot of that?
I see.
Right there?
Yep.
Okay, you can see the backfeed protector I built. This is all the diodes I had left, and it might need a few more because I'm getting a little bit of miss. But each one of these goes to one of the plugs. Is 1, 2, 3, and 4. It goes right down to the top of the plug, and it's in parallel with the high voltage wire. And I'm going to fix this up a little bit, but this is the input from off the top of here. And if you when I show you the schematic in the next video, I'll show you the schematic. You'll see that this is wired backwards and it shouldn't work, but we are getting plasma. And the interesting thing is the inverter that I have registers 0 amps current flow, and we know that the battery isn't connected during the spark, so the question is, where's the energy coming from? So we've got to keep working because we're leaving Saturday or Friday, this coming Friday, for the Midwest, and I'm going to try have a little bit of water into it by the time we leave. We'll make videos along the way maybe and keep you updated, but in the meantime I'm going to keep working on this and put the schematic together for you, so we'll see you next time. Okay, you've gotten a close-up of it. You can see here the extension cord coming back from the inverter, plugged into a zip cord pigtail, very light gauge. The hot wire from the pigtail, from the AC, comes into a microwave oven transformer, a MOT, and just goes through the primary. The secondary isn't hooked up. It's just a bias for the current. Now without the MOT in there, we get maximum current flow, still at 1/10 of an amp, but enough to actually weld the end of the spark plug together. So the MOT is just basically biasing the current. I don't know how it biases it because it doesn't change from 1/10 of an amp. But so we've got the positive side coming through the MOT. Okay, and then we've got a capacitor across the input. Got that so far? The positive side also goes directly to the engine block. So we got 120 volts AC or DC directly to the engine block. It's 120 volts DC. It's rectified through these diodes on the ground leg. This is the ground leg, the one with the knot in it. It's rectified through the diodes. It's buffered across the capacitor so that we eliminate the spaces in the negative part of the sine wave. I have a fuse in here. I don't have the fuse in the schematic, and I have a switch in here. I don't have the switch in the schematic. I don't usually put fuses and switches in schematics because that's kind of a no-brainer. But you can do whatever you want with it. The negative side, the ground side, negative 120 volts DC, comes through a series of diodes. There are 60 diodes in series, and there's 2 banks of them. You don't need 2 banks. I didn't know how much current I was going to draw, but these are 1N5408s. They're fairly cheap. You can get 150 of them for under 20 bucks. Link is on the website. And they're rated at 800 volts each, 3 amps each. So in series I have 3 amps through each one. The parallel gives me 6 amps. Nowhere near that current draw through it, but like I say, I over-designed it. You do need the series because you need to keep the high voltage from seeing a path to ground through this device. And path to ground is easier than the spark plug gap. So if you don't have a good bank to block the high voltage, you won't get a spark. It'll follow the easiest path to ground. And that's it. That's as simple as it is. Now, down inside the engine compartment here, I have another bank. You can't see them all. Actually, I can hold it up here and you can. Oops. That didn't work too well. I just got to tighten that up a little bit. This is another bank of diodes. The ground side comes out, the DC ground side comes out through this single wire. It goes down and feeds the spark plug. If you're only using one spark plug, you don't need these. But all the spark plugs are hooked directly at the top, at the anode, to this single wire that comes in here. So these diodes are simply to prevent crossfire in the spark plugs, because the spark plugs are all, the top of the spark plugs are all hooked to the same wire. So all this does is prevent crossfire. Like I say, if you're going to use a single plug on the bench, you don't need to have these. But if you can put it in a vehicle with more than one plug, you're going to have to prevent crossfire. And over here, you can see this is the airflow sensor. This is the intake hose. And I have two misters here. These are half a gallon an hour at 30 pounds. I only have one of them hooked up now because it runs quite well on just one with gas. It doesn't run for crap with two of them without gas, and I just don't have time to mess with it right now. But the important thing is that that plasma spark will fire the water mist. It's just a matter of fine-tuning it and getting it running. This is another bank of diodes. The ground side comes out, the DC ground side comes out through this single wire. It goes down and feeds the spark plug. If you're only using one spark plug, you don't need these. But all the spark plugs are hooked directly at the top, at the anode, to this single wire that comes in here. So these diodes are simply to prevent crossfire in the spark plugs, because the spark plugs are all, the top of the spark plugs are all hooked to the same wire. So all this does is prevent crossfire. Like I say, if you're going to use a single plug on the bench, you don't need to have these. But if you can put it in a vehicle with more than one. And finally, this is a shot into the engine compartment. This is the positive wire, the hot wire. Comes down from the DC rectifier. Ties directly to the engine block. This spark plug is the one you saw in the lead-in. Hasn't changed since I did the video last night. All I did was pull number 4 plug and hook it up to this test plug so that I can show you what a nice arc it made. And if you look carefully, you can see this wire here is the current wire, theoretically. Actually, I call it the dipole wire. It comes down into a connector. I've cut away the side of the plug and put a connector right over the top of the spark plug, and then plug the spark plug down on top of it. So it's really very simple. There's nothing exotic here at all. Okay, that's about it. The schematic will be published on my website. I'm also going to share it with panacea.org. And anybody else that needs it. This has to get out to the public. It has to be spread as widely and as quickly as possible because we don't want it stopped. The implications here are pretty profound. That plasma arc puts out a pretty good electromagnetic pulse. Each time it fires, there's energy there that's available. There's also the possibility of using this circuit. I've played around with hydroxy, so there's a possibility of using this circuit to produce hydroxy gas. I have no idea how it would work, but if I can produce that plasma arc for 1/10 of an amp, something should happen. So there's a lot to play around with. The important thing is that it gets out and it gets out quickly. As I said, with the amount of current draw that I'm experiencing with this system right here and the improvements in performance that I've experienced with this little camper van, for very reasonable, very easy circuitry, very low cost, you could build these for any car and improve mileage without doing anything else. And if you did this circuit and just introduced water injection and left the gas there, you might be able to lean out the gas and run on a mixture. If we add ethanol or alcohol to the water, who knows? There's a lot of possibilities here. It's pretty exciting for me, and I'm sure it is for you too. So build the circuit, test it out, join the forum. I have taken this dipole principle and applied it to magnets, and it appears on the surface that there's a way to get free energy out of magnets using this dipole principle. I won't go into detail about it, but that's going to be my next project. So if you download the video from my website, think about purchasing the book, The Path. It's in PDF format, and the binaural files. They'll help you think outside the box a little bit. Don't cost much, and it'll help my work. Thanks for watching.